Let's investigate the graph of f of x equals x squared. We have 0, 0, 1, 1, negative 1, 1, 2 and 4, and negative 2 and 4. So that's how we've plotted the points before. So you know how x squared looks like. Let's play with the a value. If a is, for example, negative 1, you can see it's the exact carbon copy of this graph but reflected across the x-axis. So negative a value reflects the graph across the x-axis. So if it's parabola facing up with positive 1, negative 1 makes it parabola facing downwards. All right, let's take a look at what happens if the a is 2. You can see that all the coordinates are stretched vertically up. What if it was negative 2? Then negative, because of negative is facing down, and again 2, so it's stretched vertically by a factor of 2. What if I make a to be 1/2? Then you can see it's a little bit wider. So you can see that our y coordinate now, instead of being at 1, 1, is 1 and 1/2. So now this is the effect of a. All right, let's make a back 1 and see what happens with h. What if h is 5? Then graph moved to 5. What if h is negative 5? Then the graph shifted to x equals negative 5. So changing about this parameter here is making the graph shift left or right depending on what number you're at. So if I have x minus minus 5, shift left 5. If it's x minus 5, it will shift 5 to the right. Let's make that h0 and look at what happens with k. All right, here is our k value. Let's make that a 3. Oh, look, it went up 3. What if I make negative 3? Then it's going down 3. So now let's make the parameter move so you can see how the k values basically makes the graph shifts up or down depending on what k value you have. What about the h value? We said that the h value determines how the graph shifts left right. So let's take the h value and make that move through different h values, and you can see horizontal shifting is what is happening when your h coordinate is changing. Let's make that a 0 and see what happens when a is, say, negative 3. So again, negative makes it point downwards, and then let's animate, and then let's see what happens to the parameter. So you can see what is happening to the graph when you change the outside number a here. So that gives you a pretty good sense of what is happening to the graph depending on whether you were changing the a value, the h value, or the k value, which allows you to read off the vertex. So y minus k, which is k is going to be your y coordinate of the vertex, and x minus h, and h is going to be your x coordinate of the vertex. And you'll see pretty much similar things happening whether you're graphing x squared, whether you're graphing absolute value x, e to the x, log x. Any of those graphs will follow the same interesting observations. So let's go to exponential graphs and see what happens. So again, our exponential e to the x graph looks like this, where 0 gives you one value, 1 gives you e value, 0 is your asymptote. So let's animate the h value and see what happens. So you can see that h is moving to the right just like before, and if I made it a negative 3, it will move to the left 3. So you're going 1, 2, 3. All right, let's take a look and see what happens if I move k equals 5. Again, everything shifted up 5, and so the effect of e to the power x minus minus 3, which is going to be the same as x plus 3, is 3 to the left and 5 up. So the point from here went 3 here, 5 up. The asymptote moved from 0 to 5 up. when the asymptote, you have a horizontal asymptote moving left right, is not going to make much difference. All right, let's investigate what happens to x squared, x to the 4, x to the 6. In general, what happens to the graph when it's x to the even power? We already know that x squared looks like this. It's a parabola, 1, 1, 2, and 4. So let's see what happens if I want to graph x to the 4th power. So 1 to the 4th power is 1. So that means that the point 1, 1 is going to also be on x to the 4 or x to the any even power. But if you take, say, half, 1/2 to the square power is going to give you 1/4, but 1/2 to the 4th power will give you 1/16, which is even smaller. However, 2 to the 4th power, 2 squared is 4, but 2 to the 4th power, which would be 2 times 2, 4 times 4, 16. So that'll be much, much higher. So if you plot that, it will look like this. Now, what happens if you have x to the 6? So you start to see a pattern. So between -1 and 1, it'll be a little wider, but after 1 and below -1, it's going to be a little bit higher. So in general then, let's say what happens when n equals 3. So that means this function here will be x to the 6th power. So this black graph right here is x to the 6. Red graph is x to the 4. Purple graph here is x to the square power. So this gives you a sense of how x to the power 2n looks like. Now, what if I wanted x cubed? Well, again, you can plot a few more points. So let's change this graph to x cubed. So here's the graph of x cubed. So again, 1 cubed is 1, 2 cubed is 8, -1 cubed is -1, -2 cubed is -8. So you can see if you just plot a few points, then you can see that x cubed graph is going to look like this. Let's try x to the 5th power. So that's this red graph here. Again, at 1, 1, they intersect, and then it's wider at the base and taller here, just like the other graph, but the shape remains very similar to x cubed. So in general then, if you have x to the power 2n plus 1, so odd power, let's see, when x is 3 then, so x to the 7th power will have a similar graph. So you can see how this black graph is x to the 7th power, red graph is x to the 5th power, and the purple graph is x to the 3rd power. So you can see the shape remains the same, except gets wider at the base as you raise the power between -1 and 1, and taller past 1 or below -1. So let's summarize everything that you have seen so far. So graphing just means that we are investigating how the different curves look a little more deeply than you had before. We'll focus on parabolas, exponential and logarithmic functions, and also functions like x cubed, x to the 4, and so on. So as we saw before, to graph equations, sometimes you just have to plot enough points, gives you a good sense of what the graphs look like. On the other hand, as a mathematician, if we explore some basic connections between variables and numbers in the equations, we find patterns like we did in terms of shifting left, right, or up, down, and so on. Those are called transformations. So if you look, generic graph of e to the power x, remember e is a number, not a variable, 2.71 something. So like if you plot a few points, you will see e when x is 1, you have e. When x is 0, you have 1. When x is -1, you have 1 over e. So horizontal asymptote for this graph is y equals 0. The inverse function of e to the power x is natural log x. In general, if I have exponential function 2 to the x, then when x is 1, I'll have 2, 0, 1, -1, 1 over 2. And I could have log base 2 of x I can have 2 and 1, 1 and 0, half and -1. And again, vertical asymptote would be x equals 0. So just remember, natural log x is inverse function of e to the x. So here are the two graphs of exponential function, logarithmic function. Don't forget the asymptotes for these two graphs. All right, absolute value x. So that's going to be this V shape. When x is 1, you have 1. When x is 0, you have 0. When x is 2, you have 2. When x is -1, you have 1. When x is -2, you have -2. So it's really a part of the line for y equals -x and a part of this line y equals x together gives us absolute value x. All right, x cubed we just saw was that graph. You just plug in some points and sketch the graph. So any function of the type x to the power n, where n is an odd number, will have this kind of shape, and the higher the power, the wider it will be at the base. So this is what we just saw. And so you can see the black graph is your x to the 7, red is x to the 5th, and y is x to the 3rd power in the purple graph. And they all go through the point -1, -1, and 1, 1. Similarly, if you have x squared graph, all even powers will have similar graphs, and the only difference is how wide it is at the base. So let's look at translations of graphs that we saw before. If you have y equals a function and the graph is given to you, and you want to know what happens to the graph of f of x plus a number, then that effect is it translates the graph of f by h units in vertical direction. So if you have a positive number here, go up that many units. Negative number here will take it down that many units. What if you have x plus h? Then you're going to translate the graph in horizontal directions by -h units. So if you have x plus 2, a function evaluated at x plus 2, you're moving the graph 2 units to the left. X minus 2 will move it 2 units to the right, as we saw. For a bigger than 1, a times f of x, this graph is stretched vertically by a factor of a units, and if a is between 0 and 1, the graph is compressed vertically by a factor of 1 over a units. So general directions to sketch graphs are: determine the original graph from the library of functions that we just looked at. Use order of operations to determine what operation is being done first. Proceed to use that information to graph the given function.